Hello guys, welcome to Digitronix Nepal tutorial session. So this is our maybe fourth tutorial session on ISE design suite on Spartan 3. Actually we are going to create a 4-bit adder, normal adder like a full adder by using Xilinx core generator, which is already in our core generator repository of ISE design suite. We are going to use that repository. So for this tutorial we have sort out some things to do, objectives and design descriptions. So this is our main tutorial session. So objective of this design session will be we will know about how to generate a core IP IP core from core generator. Then we will know about how to synthesize the design and how to instantiate and how to implement the design in ISE design suite for Spartan 3. The design description can be explained as follows. Like we are going to instantiate or call two input data, which is width of 4 bits. Like A and B are two input, which are each of 4 bits, and we will also take carry in and carry out like full adder. So asynchronous output data with a 4 bit, it will also gives output of 4 bit. So AVR input of 4 bit, output is also type of 4 bit, and carry in carry out. So these are the procedures. We are going to create a new project on ISE design suite, and we will import our top source, actually top module, which will include our IP core of 4-bit adder, and we'll call about IP core and generate IP. We'll insert adder and subtractor in our current repository. So after that we will generate IP with this feature, then we will synthesize it. We'll plan the constraint, then after we'll generate the stream and configure hardware target for Spartan 3 FPGA. So let's proceed with ISE design suite. Sorry. So let's open ISE design suite. So we are going to start from creating new projects. So okay, so let's do new project. Bit adder. This will be good. I will relocate this into, I have one project folder which is called this, and I will do next. These are the port setting for Spartan 3. Actually we have Spartan 3E development kit, which is also been shown here. So this is our FPGA board. So as your FPGA device, you have to select this feature like device and package and speed grade. So we have this. So I'm going to do next and finish. It will create just a project. So we need to have source of like we are going to add source. Sorry, actually we are going to do add copy of source, which will copy the sources to your current repository. So I'm going to here, I have here source. Okay, this is our top source. Actually what happens here is I will do remove. Actually my source is in the txt format, so it shows some difficulties. What I will going to do is I will copy, or I can do save as. Actually notepad++ also have extension of BSD, so I will do this. So it already recognized the BSD source. So now I can import this source on ISE design suite. Here copy of source top io.m. So this is VHDL. So uh, actually this source is top module, which consists of some port definition like clock, data input, data output. We already know about data input and data output. In data input there are 4 bit of two ports, 4 bit each of two ports like A and B are of 4 bit each, so that will 8 bit and carry in each another bit, so 9 bit inputs is 4 bit output and 1 bit carry, so 5 bit output. So we can say A, B are 4 bit wide and carry in is 1 bit, isn't it? So output is 4 bit wide and carry out 1 bit. So we define our port in just 2 lines. So if we want to define differently, then we can have this, and we can also have in top module. What we actually do is we define the entity of top module, and we instantiate the component of sub module which we are going to insert. We are going to insert my adder IP from IP repository of ISE, so which is like code generation. Then we have some port mapping feature. Port mapping is actually the interfacing between top module and the component, because component calling component is not the interfacing, so interfacing hasn't completed in component section, so we need to map each ports. Like we can see A is 4 bit wide, so data 3 to data in 0, so B is data 7 to data 4. So this is map in A, and clock is clock, C in is data in 8th, C out is data out 4th, and output is 4 bit wide. So now there is some question mark which shows that the source which we need is component at here. My adder hasn't been declared in the project, so what we need to do is we need to do add a new source. Type of source is this, and we are going to name this my adder. And we are going to do next. It will load the IP. If you are loading this section first time, it will take some minutes, but I think I have previously worked on this core generator section, so it might take some minutes to load it. So let's wait. It will show some IPs which are in our core generator, so let's wait. So my IP repository, actually core generator or core gen, has been open. So what we need to do is we need to select only those IP which will compatible with our Spartan 3. So I have to click on here, so you have to click on here, and we can also source here, and we are going to expand math function and this adder and subtractor. Here we get adder and subtractor IP, because this IP has been instantiated in our component section previously, which we have been architect it. So let's do next. On this option we will get some customization menu for that IP soon. So it has called the project file of my adder, so it will give us some customization menu. So we are going to change some parameters at that menu. So let's wait. If you are doing first time this core generation feature, then it might take some time, because at the first time it will call every repository IPs, and it will call the IP from its local directory to your project folder. So it has been running on, so let's wait some time. So our menu has just opened, so we need to do some customization. Actually we need just 4 bit of A input and 4 bit of B input. We are going to do addition. If you like to subtract, you can subtract it, and output will also be 4 bit. And what we need is carry in, and we can disable carry in. Actually we need another carry out too. Let's do that. Actually I just forgot to do that. We need to have operation of unsigned, so let's select A input type is unsigned, B input type is unsigned, A input width is 4 bit, B is also 4 bit. We are going to do addition, and output width also be 4 bit. So let's select and carry out also. So this is all the necessary customization on our adder. So let's you can study about this IP if you like to. Sorry, to do this IP. Okay, I just get it. We can get its dataset from, I think, internet. Let's click on it. It will. Okay, we already have its dataset in our local directory. We can study about this adder. This adder is actually made by Xilinx itself, and Xilinx put this basic IP in its core generator repository. So let's generate this IP. Actually the word question it here will disappear if our generation is successful. It will merge in this project folder, and it will be inside this my adder. So top IO will include my adder, which are going to generate. It will show some IP icons right here. So let's wait some time for this generation. It is generating the IP from actually local directory into your project directory. And the IP which we have generated will have this ports, which is instantiated at component. So actually this icon, bulb icon, bulb icon has appeared right here. So what we can do is we can click on this, and we can have instantiation of VHDL templates. We can see the VHDL program or VHDL code of our myadder IP, which we have just added. So we can double click on this, and we can go to here. So this is the ports of myadder IP, which we have instantiated at here: AB clock C in C out yes. AB clock C in C out yes. Actually it is case insensitive. There is no sensitivity on case like capital or small. So this IP has been called here. What it does is it actually calls the my adder instance, and it has port mapping. So we can see also the functional model. Okay, here is the functional model of this IP. Actually what it does is it takes inputs and it adds corresponding inputs with two inputs, and it will create a carry or borrow, and it will give the outputs with carry or borrow. This is the main functional model, and what we are going to do is we are going to synthesize it, and we are going to implement as our Spartan 3 constant. Okay, we have some error. Let me correct it. Actually we have warning. We can just neglect this warning too. Okay, let's neglect this warning. This warning can be neglected. So after this we need to have constant set for our design. Actually implementation design constant. Let's create a constant for this top IO. Actually we need to have constant of clock data in and data out. So what we are going to do is we are going to follow the Spartan 3 user guide UG230. So we can get here clock. Let's go to clock, and the constant of clock is this. We are going to just paste it. Very fast process. In fast process, actually we can do this step by using plan ahead too. So we are not going to use plan ahead. This is our clock, and we need to have data in. We are going to give data in from switch. Actually we have less number of switches and LEDs, so we are going to just adjust these switches. Actually our data in is input, so we are going to replace data in, and we are going to just paste, copy and paste it. Okay, data in is good, and now we have to have another 4 input. Sorry, I have just messed up. Actually our data in is 9-bit lengthy, so we need to have put some 9 inputs so that it can take input. So what we can do is we can just left carry bit. Carry bit is actually the 9th bit. Carry bit actually 9th bit. So let's plan until 8th bit. We are going to use these 4 switches also. Actually Spartan 3 have very less number of general programming input output. So if you have another board, you can plan according to that board. Because our input is 9-bit length width, sorry. Okay, I'm just going to change the value of array. Actually we have 3, this will be 4, 5, 6, 7, and we are going to just left the carry bit, which is actually 9th bit. Just place this it from the same port. So this will make error. So let's comment it. And we need to have output of how many? Actually output of 5. Even we can select from downstream. Okay, actually it hasn't been copied. Okay, actually our output is data out, so let's just copy from here, it will be fast. Okay, this is almost the process. So we have just left carry because lack of our GPIO. We can use our extension header, like we also have heroes connector in Spartan 3, but for using that heroes connector we need to connect our external breadboard. This can be here also. Okay, we can use this FX2 header or normal P modes. For that we need to have different headers, so we are just using these 4 switches and these 4 buttons, and we can also use this rotatory switch as inputs. We can see it here, rotatory switch, that is actually knob. but using this knob is very much difficult, so just let's do it. So let's implement it, and then we can see the further process. Clock data in and data out. I think I have placed all the necessary ports in this constraint, so let's hope there will be no any errors. We have one significant warning at our synthesis process, but I think there must not have errors. It is still running, is creating timing signals. Okay, that's good. So now we need to generate PT stream, and currently we haven't have connected Spartan 3 with our computer, so it will take time to connect Spartan 3. So we will create another video session on how to upload this generated PT stream into Spartan 3. So I am going to show you just steps what we need to follow for programming or configuring the target device or FPGA. So just double click on it, it will open impact, and in impact we are going to do boundary scan, we are going to do initialize chain. It will give 3 devices if you have connected properly. Then we can select yes, and then we will locate the BT stream of current project. Project is here at your directory, isn't it? Here. So after that we will click yes. Then after we will click bypass for PROM and CPLD. Then after we will do apply and OK. Then after we will click on first chip, which is FPGA, and we will click program. If the program is succeed, then it will show up here. Then you can see your output in your Spartan 3 or any other board. So this is the overall steps of creating a 4-bit adder using Xilinx core generator. This is our tutorial session. So you can see the how much resources LUTs actually we have used. Actually Spartan 3 have 9312 LUTs, and it has just used 5 LUTs, means that is very less number of LUTs. So we can see resources and other reports also here, resource utilization and other reports. So guys, you can have this UG 230 user guide 230, you can Google it, you can get it from Xilinx. Then it will be helpful for creating constraint. There are another process for creating constraints also, because you can also use this floor plan area IO logic, but this program is quite slow in many computers, so I haven't opened it because you might get stuck in that application. But my computer can run this quite fast, but writing constant by using this user guide is very much easy. So I have just followed just adding new source of implementation constant file and editing it with this type of sources. So guys, this is the all tutorial about fourth tutorial in ISE and Spartan 3 about creating 4-bit adder using Xilinx core generator by Digitronix Nepal. Guys, keep streaming on our YouTube channel. We are going to make more videos on Spartan 3, Zboard, Zybo, Pink, and Nexus FPGA. So you should get lots of information from our website. So keep streaming us, and this is our instruction, and we will meet you in another session. Thanks for watching.